The global collagen market generates $12 billion every year. It sells processed animal proteins in jars and capsules, collagen creams that cannot penetrate the outer layer of your skin, and powdered supplements that your digestion breaks down into amino acids your body sends wherever it needs protein, not specifically to your face. Meanwhile, 5 plants that actually signal your fibroblasts to produce their own collagen grow in backyards across 4 continents, documented in peer-reviewed journals, used in traditional medicine for thousands of years, and almost completely unknown to the consumers spending billions trying to solve the problem they address for free. Welcome to Hydrohaven. Subscribe if you haven't. We cover the practical and the suppressed in equal measure, and this one sits firmly in both categories. Now, 5 plants, the biochemistry behind them, and the economic structure that kept them from you. The reason you haven't heard about these plants is not ignorance, it is economics. You cannot patent a plant that grows wild in the wetlands of Sri Lanka. You cannot trademark a berry that self-seeds across the mountains of Tibet. You cannot protect a flower that blooms in every tropical garden from Mexico to Malaysia. When a solution cannot be owned, it cannot be sold at premium prices. When it cannot be sold at premium prices, it does not receive marketing budgets. When it does not receive marketing budgets, consumers never learn it exists. This is not conspiracy, this is accounting. So here's the thing. Collagen molecules applied topically are actually too large to penetrate the outer skin layer effectively. And when you take collagen supplements orally, they're broken down into amino acids during digestion. Your body just uses those amino acids wherever protein is needed, not specifically where you want, say, younger skin. The real mechanism for rebuilding collagen is internal stimulation. Your fibroblasts need to be signaled to produce new collagen. They require the raw materials, the cofactors, and the molecular triggers that tell them to activate. These 5 plants provide exactly that, and honestly, all 5 of them have been doing it for centuries before any laboratory confirmed why. Before we go any further, just a quick personal note. I rescue injured dogs, animals that honestly had nowhere else to go. Before this channel was demonetized, I was caring for 10 dogs. I've now been forced to cut down to 5. Some had to leave before they were fully rehabilitated, relying on kind people to take them in because I simply couldn't keep up anymore. Right now things are difficult. There are days they eat leftover food from restaurants. Not because it's right, but because it's what's available. They still need proper care, food, and a chance to recover fully. If this channel has helped you in any way, and you're in a position to help, the PayPal email is in the description. Even a small amount goes directly toward their care. Thank you for being part of this. The first is Gotu kola, Centella asiatica, and the research documenting what it does to skin fibroblasts is honestly among the most thoroughly validated botanical science available in peer-reviewed literature. Gotu kola grows across the wetlands of Asia, from India to Indonesia, from Sri Lanka to southern China. Its leaves are small and fan-shaped. Its stems creep along the ground, rooting at nodes. In Ayurvedic medicine, it's been used to treat skin conditions for thousands of years. In the West, when it is known at all, it appears briefly as a trendy skincare ingredient, but almost never with any explanation of the mechanism behind it. That mechanism was first formally studied in 1990, when researchers examined TECA, a titrated extract of Centella asiatica, on human skin fibroblasts. The active compound responsible for stimulating collagen production was identified as Asiatic acid. The mechanism involves the transforming growth factor beta receptor pathway. Essentially, the extract sends a molecular signal to fibroblasts, instructing them to manufacture more collagen. This was not a cosmetic effect. This was not temporary plumping. This was the actual machinery of skin cells being activated to produce structural protein. A 2025 clinical study across 88 female participants with sensitive skin found mean symptom scores dropped by 66% after 2 weeks and 76% after 4 weeks. A separate pilot study showed statistically significant improvements in all skin parameters in the treated group compared to placebo. The European Medicines Agency published an assessment report on Centella asiatica documenting that the plant promotes fibroblast proliferation, increases synthesis of collagen, increases intracellular fibronectin content, and increases mitotic activity in the germ layer of the skin. This is regulatory body documentation based on clinical evidence. Yet ask most pharmacists about it, and you'll get a blank look. The second is sea buckthorn, Hipophy rhamnoids. And what makes it significant is not one compound, but the combination of properties that no other plant source in this category shares simultaneously. Sea buckthorn grows on high-altitude mountain slopes with freezing winters, poor soil, and intense ultraviolet radiation. From the Himalayan plateau to the coastal regions of Russia, from Mongolia to the mountains of northern Europe, this thorny shrub survives where almost nothing else can. In 2008, Harvard researchers identified that sea buckthorn is one of the very few plant sources of omega-7 fatty acid, palmitoleic acid, which is naturally present in human skin and plays a role in cellular communication and tissue repair. In 2022, Chinese researchers published findings showing that sea buckthorn proanthocyanidins promoted the synthesis of type 1 collagen through the TGF-beta 1 pathway, while simultaneously inhibiting collagen degradation by regulating the balance between matrix metalloproteinases and their inhibitors. In plain terms, the extract both built new collagen and protected existing collagen from breakdown. A further study demonstrated that sea buckthorn extract enhanced collagen expression in senescent fibroblasts, aging skin cells that had slowed their production, essentially rejuvenating the manufacturing capacity of old cells. A clinical trial on skin aging found that topical application increased cutaneous thickness, suggesting positive structural changes in collagen synthesis. Grandmothers in the Himalayan foothills have been pressing these berries into oil for generations. The laboratory caught up with them about 30 years ago. The marketing never did. The third is Horsetail, Equisetum arvens, and its significance lies not in a compound but in an element, specifically silica, and the enzyme that cannot function without it. Horsetail is one of the oldest plant species on Earth, appearing over 350 million years ago. It grows in ditches and wetlands across temperate regions of every continent except Antarctica and Australia, and up to 25% of its dry weight is silica, the highest concentration of this mineral in any plant on Earth. Silicon is required for the activity of prolyl hydroxylase, the enzyme that catalyzes a critical step in collagen formation by hydroxylating proline residues in procollagen. This hydroxylation is necessary for the collagen triple helix to form properly. Without adequate silicon, the enzyme cannot function efficiently. Without efficient enzyme function, collagen structure is compromised. As humans age, silicon levels in the body decrease. This decline correlates directly with decreased collagen production. A clinical study on postpartum wound healing found that an ointment containing 3% horsetail extract promoted healing and pain relief, with researchers attributing these effects to the plant's silica content and its role in collagen synthesis. It also contributes to glycosaminoglycan formation, compounds that maintain skin hydration and structure alongside collagen. Horsetail grows wild everywhere. Farmers spend money trying to eliminate it. Nobody needs to buy it. A plant that costs nothing generates no revenue. A plant that generates no revenue receives no marketing budget. The fourth is Amla, Emblica officinalis, and its relationship with collagen runs through the single most important cofactor for collagen synthesis in the human body, vitamin C. Amla is a small, deciduous tree from India, producing round greenish-yellow fruits approximately the size of golf balls. It contains approximately 20 times more vitamin C than an orange. Vitamin C is not optional for collagen production. It is the cofactor for prolyl hydroxylase and lysyl hydroxylase, the enzymes that stabilize the collagen framework. Without adequate vitamin C, collagen production fails. This is why severe deficiency causes scurvy collagen breakdown throughout the body. In 2008, Japanese researchers published findings in the Journal of Ethnopharmacology, showing that Amla extract dramatically decreased MMP1 production by fibroblasts, MMP1 being the primary enzyme responsible for collagen degradation, while simultaneously increasing TIMP1, the inhibitor that blocks matrix metalloproteinases, less destruction, more protection, and simultaneously, the extract stimulated procollagen production. It was not just preserving existing collagen, it was promoting the manufacture of new collagen. The researchers concluded that Amla works effectively for therapeutic and cosmetic applications through control of collagen metabolism. The vitamin C in Amla is also more bioavailable than synthetic ascorbic acid, because the whole fruit matrix contains bioflavonoids and other compounds that enhance absorption. Yet Amla remains largely unknown outside South Asian communities, because it grows in tropical climates for free, tastes sour and bitter, and cannot sustain the premium pricing that drives marketing investment. The fifth is hibiscus, Hibiscus subdarifa, and dermatologists have a nickname for it that tells you everything about the research behind it, the Botox plant. That nickname is not marketing. It refers to specific biochemical mechanisms. A study reported a 60% increase in collagen synthesis when hibiscus extract was applied to skin cells, alongside a 16% boost in fibronectin production. But hibiscus does something additionally valuable. It inhibits elastase, the enzyme that breaks down elastin, the protein that allows skin to stretch and snap back. The compound responsible is myricetin, a flavonoid that suppresses both collagenase and elastase simultaneously, protecting the two primary structural proteins of skin at once. Additional research confirmed that hibiscus extract shows collagenase inhibitory activity, not just promoting collagen production but preventing collagen destruction. Hibiscus grows in nearly every tropical garden. In Jamaica, Egypt, the Philippines, Thailand, Mexico, the flower is everywhere. The knowledge persists across cultures. The science confirms the mechanism. The economics ensure the marketing never reaches the people who need it. 5 plants, 5 documented mechanisms, 5 botanical solutions that the collagen industry had no financial incentive to reveal. They are still growing, they are still available. The only thing that changed today is that you know their names. Subscribe to Hydrohaven. See you in the next one.